So to continue 1.6, now we're reminding ourselves again for increasing, and again we're reading the graph left to right. I should do a different color. So G, as a reminder, is the solid, and as we read left to right, it's not going up until we get to here. And again, some teachers might argue with you on what the correct answer is, but I would say to the left is increasing and to the right is increasing. So I would just go ahead and include all of these values from -6 until I get to 3. And I'm going to practice using brackets. I know some people might disagree with this and say that those should be parentheses. And you might actually see an answer key of mine that uses parentheses there instead. But increasing and decreasing and constant, it's kind of an argument amongst math people, if you remember from the previous video. But G, the solid line, is also increasing from here to here. And again, you might get into an argument, but I'm going to use brackets, 9 to 11. All right, and I don't want to get into, just know increasing and decreasing, I will accept both brackets and parentheses for all of these answers. Same. So if for some reason I mark it wrong, just say, hey, Mr. Higby, you told me it was okay to use both. And I will say, you know what, you're right, and go back to it. Okay, so decreasing is everything from 3, and again, some people might argue with me that it changes slopes, but it's still decreasing. So from 3 to 9 is where G, the solid line, is decreasing. It's going down and to the right. And then constant is where it's a horizontal line, and that's from -11 right here until -6. And again, I'm going to write it with brackets, -6. But I will accept correct answers if you change these to parentheses. Okay, and I get the argument. I don't necessarily agree with it, but I get how somebody might say, well, how can you be increasing and decreasing at the same time? Well, you can't, but there's another rule in math that kind of supersedes that. So same thing with 9. You can't be increasing and decreasing at the same time. That doesn't make any sense. But there's a reason why they make that exception. So continuing on, same thing. Now we're looking at where F is increasing. That is the dashed line is going up and to the right. Well, it's going down, 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 down. It's down until we get to 3, until it increases forever after that. So 3, and we always use a parenthesis with infinity. That's not really up to debate. Now decreasing for F, the dashed line, it's definitely going down. Well, it's undefined at -9, so it wouldn't make any sense to put a bracket there either. So from -9 until -6, and I'm going to go back to a bracket there, and it's also decreasing once we get from x is -1 to x is 3. I keep forgetting to write my negatives. Sorry about that. And then constant is the horizontal line. That is this little piece right here that goes from -6 to -1. Again, back to using brackets. All right, let's answer a few more questions. I think we saw this in a previous video. Remember, if you just think this is f of x being less than 0, that is below the x-axis. Now, this is what getting back to me caring about brackets and parentheses, because we don't want it to be on the x-axis because it's not equal to, it's only less than. So where's the dashed line below the x-axis? I feel like we already answered this, but it goes from 1 to 15. From 1 to 15. Now we get into a tricky question. I know we haven't seen it before, but let's think about it. What does it mean for the y values, when we multiply them together, to give us a negative value. Basically what it boils down to is the signs must be different. So let's say f is positive above the x-axis. The only way to get a negative value is if g is negative. A positive times a negative is negative. So if f is above, g has to be below. Well, where does that happen? Where f is above and g is below? Well, definitely from -9 until about -4.5. F is above and g is below. So let's write that down. You don't want to include -9 because it's undefined for f. And you don't want to include -4.5 because g is 0 there. And now from here, for a long while, they're both above the x-axis. A positive times a positive is positive. It's not until we get to x equals 1 where 1 is below and 1 is above again. And they flip, spots now. So from 1, again, with a parenthesis, it's very important now, until 6, because now they're both below the x-axis once we get to 6. And why does that matter? Well, now it's a negative times a negative, which is positive. But that's not your only other answer, because from 10.5 to 11, kind of ran out of space, 1 is above and 1 is below. And now I can include 11 in the bracket because it's a defined value here and a defined value here. So don't forget about that either. And then this is the same question except the opposite, because now it's a positive. Basically what that boils down to is the signs must be the same. And what makes this question now really easy, if you understood the previous one, is the function is only defined from -5 to 11. That we can compare both of them because it's undefined past those. So if it didn't work, that multiplying them together gives you a negative, then they must be everything else. So the answer must be from -4.5 to 1, and then union from 6 to 10.5. And we can confirm that they're on the same side of the axes by looking at from -4.5 to 1. Both curves are above the x-axis. And from 6 until 10.5, they're both below. And what happens if you have a negative times a negative? You get a positive. Okay. Throwing in something from a long time ago is asking you to come up with the equation of a piecewise function, which I believe we did earlier. What might help some of you is to write out the bounds first, that this linear function is only defined from -6 until we get to -3, and then worry about coming up with the equation of that line. Well, it looks like to me that that slope is up 2 over 1, and then if we continued that trend, where would it cross the y-axis? I would say 7. So then the next interval goes from -3 to x until, and we want to include because it's bounded, x is 1, and then just look at, oh, it's a square root function flipped over the x-axis, so that's a negative square root function. Looks like it shifted left 3, so we write x plus 3, and then up 1. And then this last one definitely looks like a parabola, but let's do the bounds first. Undefined when x is 1, and then defined when x gets to 5. And I would just leave it as the vertex form, which I think you're all familiar with, that it shifted right 3, so x minus 3, up 5, plus 5. And don't forget that it's reflected, so stick a negative in front. And I kind of messed up putting a negative in the way. I guess I should clean that up, make it look pretty at least. There we go. Whoops, and it changed colors on me. Okay, now the domain, I would just look at the graph to define the domain because I would read it left to right. So as we look, it is definitely defined at -6. So use a bracket, and it's not undefined until we get to this value, which is -3. But it's an open circle for both values, so it's a parenthesis to stop. Now, some students get confused because they want to stop right here, but x is defined at 1 and directly to the right of it, so we don't actually have to stop until we get to 5 and use a bracket there. Now, here's the thing. If you were to stop at 1, put a bracket, and then write some more, I would give you full credit. But mathematicians prefer seeing answers written like this. So I'm going to commit to that answer. Now the range is from the bottom to the top. So -5, if I'm counting correctly, is the lowest y value. And when does it stop? Some people say, well, it stops at y equals -1. That's true, but it's also defined directly above that. So all of these values are defined. Now some of you might say, well, this is an open circle, so we have to stop at 1. That is true, this is an open circle, but there is definitely a y value at y equals 1. So we don't have to stop there either. It doesn't stop until we get to y equals 5 with a bracket because it is closed up there. Again, if you write more than this, this is the shortest way to write it. But if you write something that's equivalent, like you stopped at -1 with a bracket and then kept going, I will give you full credit, but mathematicians prefer writing it like this. Okay, so now with the next part, p of x, I think it's probably easiest if you graph this problem and actually graph, because this is the absolute value function. It's a V shape, shifted left 1, up 3. So left 1, up 3. And with the negative, that means it's a downwards V. So it looks something like this. Put a little arrowhead here. And then also goes in this direction. And hopefully you're not drawing too harshly over things because they would intersect. That's what I'm looking for. I'm looking for points of intersection. The problem is where they would have intersected are open circles. So those are undefined points, so there's no solution here. So I'm trying to think of other ways that might explain this. And you really don't want to try and set p of x equal to h of x and solve all three of these because you will get values that work. That's why I said it might be in your best interest just to graph and see where the points intersect, because that's the only way you can get the y values to equal. And you can visually see that where they would have intersected are actually holes in the graph. I'm not going to try and rush through and answer the rest of these questions, so I'm going to pause the video and we'll finish up. It shouldn't be a long video, the rest of this.